In this video, I'd like to take a closer look at what we did when we created the table, and in particular at the key. And here we have this key, and remember, I had just done it myself, just using the movie database. That was that sample, but you're doing it with this AdventureWorks one. And we have the key schema, and this is, typical Python list with dictionaries inside it. So the key schema is a list, as you can see, and it has two dictionaries, one for each of the attributes that make up the key. You'll notice that you've got the word hash and you have the word range. And then in a comment, they talk about the partition key and the sort key. So you'll see kind of that mix of terminology if you were to look at the documentation. I just want to explain what this notion of hashing and partitioning and hashes and ranges really means, because it has a pretty deep meaning in computer science, and it applies to a whole bunch of stuff. And the underlying data structure of a DynamoDB database, of a document store database with its keys and values, and we're seeing so much about keys and values here. It has to do a lot with this notion of hashing. So I'd like to talk a little bit about what hashing means, and we'll see that it applies to a broad range of things, and there's some stuff in your database textbook that I'll point you to as well, even though it wasn't required readings in my section. I don't think in any of the sections of the database class. It was in chapter 5, but I'm going to take you to it to kind of show you also other applications of this notion of hashing. You've probably heard the term hash before. Certainly if you're in 484, I would imagine that by now you've learned how to hash passwords. So let's take a look at what this hashing really means. So hashing is a function. So a function is taking an input and it's producing an output. Typically what we're seeing, as you can see in this diagram, that the input is in the form of maybe a string or something like that, and then the function applies to it and it produces a value of a specific length. In other words, there is a certain finite number of possible values that there can be from a hash function. And it applies all over the board. It applies to a lot of things, as I said before. But the idea, here's this notion of a key and then a value. So you can think of the input as the key, and the value, whatever value comes out, as the range. And we'll talk more about that. As this diagram is showing, you'll notice that it's possible for more than one input to produce the same hash value. So a function is going to just give you some limited number of possible values as an output. So for example, maybe the hash function was going to give you a number between 1 and 10. Now, so whatever comes in, it's going to do some algorithm that's going to produce some number between 1 and 10. So there's only 1 through 10 as the possible numbers. Well, it's possible that there might be many inputs that would give you that same hash value. That means that there's something called collisions in hashing, and we make use of those collisions, or we try to avoid them depending on certain circumstances. But point being, a hash function can produce collisions. And this was a 4-bit hash function, as you can see. So here were the possible combinations: 00, 01, 02, 03, 04, 05, and multiple different names. John Smith and Sandra D both produced a 02. So you can have collisions. Okay. So hash tables are used in a lot of things. The hash table data structure is kind of like what we're seeing with DynamoDB, but we also see that in the Java class library. You'll see classes called hash map or hash table, and it's the same kind of idea. Key value pair. In fact, you can think of a dictionary as kind of like that, because key value pair. It's also seen in the underlying file organizations for a database. When we think of a relational database, we're thinking about tables and rows and columns and things of that nature, but that's not the underlying file organization. The underlying file organization may be a number of different types of organizations, one of which is a hash organization, and we'll talk a little bit more about that as well. Cryptography, I don't think I'm going to spend a lot of time with that. I'll just show you a couple of things real quickly about that. But anyways, hashing is all over the place. We may be thinking in terms of these kinds of data structures on the right, but behind the scenes, down closer to the hardware level, more like this stuff is happening. Okay, so what happens when you have collisions? Think of it this way. You have here are the different keys, and as we see, Sandra D. and John Smith both went into this particular bucket right here. So what you wind up happening then is that bucket is going to wind up having a list, be a header to a list. And here's the record and here's the record. So we're combining hashing with lists of things that were hashed to the same bucket. Let me go back to the create table here that we did. We have a hash and we have a range. In our case, the hash and the range was kind of superfluous because the product ID by itself was a unique identifier, right? So there's only going to be one product name for that product ID. But in principle, you could have a hash with a range that have many possible. If you could have the same product ID with many different product names, that would be allowable in the structure that we created. So again, look at it this way and tie it with this. We have two different people hashed to the same place, and so therefore we have kind of a list of possibilities. So the range would essentially be that list of possible possibilities. In our case, it was kind of superfluous to make the product name part of the key schema. The only reason I did it was because we used the movie example. It had a composite primary key, if you will. It had both parts to it. You don't have to have a range part in your key in DynamoDB, but we do. And as a matter of fact, if you want to try it without it, you can do that. If you did it without product name being in the key, then that would mean you don't even have to have a product name because everything else is optional, only the key. So maybe one advantage of having product name of the key, even though it's just the range is only one level, there's only one item in that range. Maybe at least it requires you to use the product, to have a product name. So if you want product name to be required, you could make it part of this key schema. So at any rate, in principle, from a given hash, you can have many possible values in your range. And we're kind of seeing that here. From a given hash, we have multiple items. And this is a very common data structure in RAM, and you might even code that. If you're doing some coding, you might even wind up coding a hash map where you have the key as a string and the range, the value is an array or a list or something like that. Okay, let's talk about database organizations. Before you had relational database organizations, some of the hash file structure was a very common use in the database. And I actually worked for a company, Michigan Bell Telephone Company, way back before we had deregulation. It was a utility, and AT&T was basically the monopoly of this. And Michigan Bell Telephone Company, as all the baby bells were subsidiaries, and we had a database that was a hash file organization database. I worked on it myself. It was called BFITS. We called it Big File in the Sky, a homegrown database, and it was a hash file organization. And there's other organizations too, and let me take you to the textbook. I'm sure you probably never read this, but I'll just take you to the textbook and show you. This is chapter 5, and they talk about this hash file organization. This notion of the hash algorithm for the file structure. At any rate, I'm not sure why I did that, but just to point it out to you. Oh, indexed and sequential and bitmap. Well, let me go back to indexed and sequential here. They show you indexed and sequential as well. Here are some of the underlying file structures for a database, possible file structures for a database. File organizations. So this is on page 221. So one possibility is a heap file, a heap. Well, you kind of have an idea of what a heap is if you've done stack and heap stuff, which you're hopefully learning in 331 or have learned in 331, maybe even a little bit in 221. We teach that stuff. So that's one kind of an organization. In the Java virtual machine, your objects are stored in the heap, so that kind of an organization. Another one is a sequential file. Well, in a sequential file, actually physically, things are stored sequentially. So if I wanted to find Seminoles, what would I have to do? I'd have to start at the beginning and read Aces, Boilermaker, Devils until I get to Seminoles. Well, that's not a very efficient file structure. And then there's index file structures, so that's a possibility. And then again, there's the hash file structure. So the underlying file structure of the database, of Oracle, of SQL Server, is not tables and columns. That's just what is given us. It's something deeper, and this is one of those deeper things. Let me just talk a little bit about cryptographic hashing. You would have, if you're in 484, I imagine you have learned this. Is there anything I want to show you on the slide? But hashing is used for cryptography as well. As a matter of fact, I think I have a Wikipedia thing up here. So this is cryptographic hash algorithms and MD5 and SHA1. I'm guessing that 484 students have already kind of had a little bit experience using it. If you look at the AdventureWorks database and you look at there's a password table, and the passwords are hashed. And hashing is not the same as encryption. Hashing is a one-way street. With encryption, you can encrypt and then you can decrypt. So you can have it be a garbled message and then you can ungarble it. Hashing goes only one way because nobody's supposed to know your password. The only person who's supposed to know, nobody's supposed to have your password stored and readable in any way that will eventually become readable, even through decryption. The only person who should know your password is you in your own head. So all that matters is that you put in that key, and that key goes for the hash algorithm, and it's coming up with a hash value of a certain size. So look at the size of the MD5 one. That's 128 bits. That's a lot of possible numbers. 2 to the 128th power. That's a lot of buckets. And similarly, this one is 160 bits. So you're not going to get a lot of collisions with something like that. You still possibly could, I suppose. It's in principle you could, but with something that big, chances are you're not going to get a lot of collisions with something like that. Anyways, that was my little digression from doing our coding stuff. So in our next video, we'll actually learn how to do some querying of the DynamoDB database. So in a sense, we'll be doing the document store equivalent to a select statement.